Hello everyone, in this video we're going to talk about performing translations. So we'll talk what is a translation, what is a transformation, and then how do we actually perform a translation. So first of all, a translation is in a larger or over an umbrella of this word called transformation. Okay, so there's like 4 or 5 different transformations. There's transformations of shapes, there's transformations of functions that you'll look at in algebra, and going on forward from there. For now, we're going to look at what's called a translation, okay? And in later videos, we'll look at what's a reflection, what's a rotation, so on and so forth, okay? So a transformation just changes a figure into another figure. So we have an original shape, or sometimes called a pre-image, and then we have the new shape, or also referred to as the image of the pre-image. So in this video, we're focused on the transformation known as a translation. So those two words, very similar, but a translation is just a type of transformation. Okay, so what does a translation do? Well, it slides a figure. Slides it, but it does not turn it. So the orientation of the two shapes should be the same, because all we are doing is shifting left, right, up, down, or sliding the shape. Okay. All points of the figure move in the same direction, in the same distance as well. So if we're moving right 3, left 4, up 2, down 5, all points of the shape, all vertices of the shape will move the same distance in that same direction. Okay, so we see an example here. We have a square and we are just sliding it to the right. Okay, so let's look at a couple examples here and let's just decide, could this be a translation? Yes or no, and why or why not? So number 1, we have 2 rectangles. Okay. But if we notice, this first rectangle in white is a little more elongated, it's upright. But then when we go here, now we've turned the shape. So we know a translation, it involves a slide, but it does not involve a turn, right? So we would say no for number 1, because those shapes' orientation is not the same. All right, but look at number 2. We have 2 triangles. Looks like we moved a little bit to the right and a little bit down, but the size is the same, the orientation is the same. This one looks good. That one is a translation. All right, number 3, it looks like the orientation is the same. We just slid it to the right, but notice how the black shape is much larger. So the size actually changed. So this is going to be not a translation. Okay. All right, now how does this work in the coordinate plane? So let's say we have a graph, right? X-axis, Y-axis. How does this actually change the coordinates of points? So we can translate h units horizontally and k units vertically. All right, these two are just variables. You could use a and b or whatever you want. I'm just using h and k. You'll see those letters later on when you get to Algebra 1 and so on and so forth. To translate h units horizontally and k units vertically in a coordinate plane, add h to the x coordinates and k to the y coordinates of the vertices. So what this is going to look like is something like this. So we have our original point, x comma y, and it is becoming x plus h comma y plus k. All right, now we have a little chart here just to kind of help us think about which direction our points are going to move. So on the left we see h. So that is going to be our horizontal movement. Well, h could be 2 different kind of numbers, right? It could be positive, it could be negative. I guess it could be 0 as well. That just means you're not moving horizontally. So we're going to focus on positive and negative. If h is positive, we're going to move to the right. If h is negative, we're going to move to the left. For k, if k is positive, we're going to go up, and if k is negative, we're going to go down. Okay, so let's look at some examples here. We could look at this as shapes on a coordinate plane and physically move them, but we can also just look at the coordinates and perform the translation by following how many units it's telling me to move and just adjusting the coordinates. So number 1, we have 3 vertices, 1, 2, 2, 5, and negative 2, 1. And they want us to translate these 3 points 3 units left and 3 units up. So h would, essentially we're going to subtract 3 because we're going to the left, right? And then for k, we are going to add 3 because we are going up. So we look at 1 comma 2, and our x coordinate is 1, so let's subtract 3. So 1 minus 3, that's going to give us negative 2. And then 2 plus 3 would be 5. So that point would now be at negative 2 comma 5. All right, for b, we're at 2, 5, so 2 minus 3 would be negative 1, and 5 plus 3 would be 8. So 2, 5 moves to negative 1, 8. Negative 2, 1, we're going to do negative 2 minus 3, so that would be negative 5, and then 1 plus 3, which would be 4. Okay, so those would be our 3 new vertices, or the image of those initial 3 vertices. All right, number 2, we have 3, 0, 0, 2, and negative 2, negative 2. We want to translate 2 units right and 4 units down. Well, 2 units right, that's going to be h, and we're going to add 2 to the x coordinates. And 4 units down would be k, and we're going to subtract 4 from the y coordinates. Okay, so a is 3, comma 0. So x is 3. Let's add 2 to that. So that would be 5. And then 0 is the y coordinate, and let's subtract 4. 0 minus 4 is just negative 4. So 3, 0 ends up at 5, negative 4. B is 0, 2. So let's add 2 to 0. So that would be 2, comma. And then we're going to subtract 4 from 2, which would be negative 2. So B goes from 0, 2 to 2, negative 2. And lastly, C is negative 2, negative 2. So let's add 2 to our x coordinate. Negative 2 plus 2 would get us to 0. And then subtract 4 from the y coordinate. Negative 2 minus 4 would get us to negative 6. Okay? So negative 2 would become 0, negative 6. All right, and that's how you can perform some translations. Now, this will continue into geometry, so I have a separate video that I've made for my geometry course. I'll link that in the description below if you want to see kind of how this translates into high school geometry. All right, but for now, that's how you can perform some translations.